All right, these are power problems where the work is not specifically given to you. You have to calculate it. It's really no different than anything we've done, just adding a step. So in this situation here, we are lifting a 5 kilogram object, and we're lifting at a distance of 1.2 meters. So remember, if it's 5 kilograms, it has a weight of 50 newtons pulling it down. So that means in order to lift it, we have to at least give it 50 newtons upward. And so we can calculate our work because we have our force, 50 newtons that we're lifting it with, times the distance that we're lifting it, 1.2, and that ends up being 60 joules. So that is the amount of work done. So in the last problem, we were just given this. We just had to calculate that real quickly. Now the amount of time it takes to do this, according to the problem, is 0.6 seconds. So to find our power, it's just a matter of saying, okay, 60 joules divided by 0.6 seconds. And if I do that, I get an answer of 100 joules per second, or 100 watts. And that is our power output for this particular job. All right, here's another problem. It says it's 100% efficient, which is nice because it's one less thing we have to worry about. But we have a power output of 300 watts. So power is 300 watts. We know our time is 1 minute, but again, it's usually best just to convert that to seconds right away. And we're trying to figure out how high we can lift it, a certain object. Now, right away, you might notice we have power and time. And if we have power and time, that means we can find work. We might not know what to do with this information yet, but if you know power and time, we have the equation, power is work over time. Let's just solve for work, even if we're not entirely sure what to do for it yet. So that means that 300 equals work over 60. So cross multiply, W times 1 is work. 300 times 60 will be 18,000 joules. And again, to double check that, I can just plug 18,000 in and 60 in, divide those, and make sure I'm getting 300, which when I do that, I do get 300. So now I know my work is 18,000 joules. All right, now what do I do with that? We're trying to lift a 200 kilogram object, which means, again, that's a force of 2,000 newtons. So we have to lift with a force of 2,000 newtons. And we've already accounted for the time when we did figure this all out. We know that we perform 18,000 joules lifting this object. So that's our work, and the force that we're lifting is 2,000 newtons. So we know work equals force times distance, so that's what we're solving for, is distance. So 18,000 joules equals 2,000 times d. Solving for d, we get 9 meters. And so that is our answer. It is 9 meters is how high we can lift this in 1 minute. So really it's just two problems in one. It's a power problem to find the work, and then it's a work problem to find the distance. But as long as you're keeping track of each of your units, writing things down, even if you're not sure how to complete the problem, you can make progress, and then hopefully doors start to open as you go through it. So until next time, I am Derek Genova. Have a delightful day.